Hey folks, welcome to another edition of the Metal Mill 52 workshop. We've got a project right now I'm working on. Is the universal pillar tool, the drill head, and I'll do this video like I did a lot of the other segments the last few videos. I'm going to try to keep it a little shorter though. I notice people don't watch the whole 15 or 20 minutes, so I'll keep it a little shorter. Give me feedback. Tell me what do you watch. You know, I get some statistics from YouTube, but it's really hard for me to know if something's the appropriate length or not. I'm not a master machinist. I'm just a hobbyist. So certainly what I do is no perfect example. I'm just trying to show an example of what a hobbyist can do, and perhaps a little bit of information about how things fit together and work together and so forth. So let me do this. Let me set up the camera here. I'm going to flip it around. Actually, pardon the hands. As you know, I'm doing this with my iPhone. I've got it. There we go. Okay. You can probably see right here. This is the spindle for the drill. On top is the brass plate that I talked about making, and it's supposed to be 3/32 inch thick, and I didn't have a 3/32 inch brass plate. So what I ended up doing was I laminated a 16th and a 32nd inch piece together. So there's two pieces laminated. My JB Weld experiment did not work, but I used some green Loctite and let it set overnight, and that did work fine. So I've got it all turned down. If you want to see some pictures of the process, go to my page on Instagram. It's the same name. Right now I've just finished, let me see if I can take the camera and show you. I've just finished the initial 3 holes here. Hopefully you can see them. And I used the center drill that you would obviously use to get started to test and make sure that the 3 holes are equally spaced. And I used my Grizzly DRO. I really do like this thing. It's hard for me to remember. I had trouble getting it to work exactly right. But I think the error I was making was that I was in incremental mode instead of absolute mode before I set up the pitch circle diameter setting. So anyway, without further ado, what I'm going to do here, I'll put the camera back. I'll show you what I'm mounting this thing on. I've got a little arm here that you use for a test indicator, and this camera protector case has a clip on it. So I've got you clipped on there, and lo and behold, that looks alright. So like I said, I just finished center drilling these things, and as you'll note, there's this big unsightly bolt sticking through here. You might wonder about that. I did that on purpose, and the reason I did was I was able to use that in the drill chuck to mark my 0 spot. Alright, so now I've got a number 50 drill. Now that I've got everything center drilled, I've got a number 50 drill, 50. I'm going to let it stick out as long as I can. Now you're going to see a little wobble there on the drill. Don't be alarmed about that. I'm just drilling tapping holes. This is a tapping size hole for 256, which I have a tap right here for. So what I'm going to do is go around and drill all the tapping holes, and then I'll come back and tap them. And I'll show you the whole process here. So what you probably saw I lowered it down. I'm going to set my DRO, because I've also measured how deep I can make these holes, or calculated that rather, and it's about 300 thousandths of an inch. You don't want to make them too deep, or it'll go down through the steel pulley into the area where the belt's going to be. Alright, I'm putting a little cutting fluid up on the spot and on the drill. Crank it up. This is not proper procedure to hold it, but I just don't want anything twisting. Okay, so I'm watching my DRO. Be because it's such a tiny drill, I'm going to just peck. We got about 60 thousandths cut now. 80, 90, 100. Alright, and clean the drill off. And check my numbers. 343 thou deep is what I'm looking for this spot. Alright, there's 150. It's unnerving because the little pieces of brass are hitting me. Before I put this in place, I also used some crazy glue to lock the to glue the brass plate into the top, and it'll come out pretty easily. But there's 250. Looking for 343 for my depth. Top of the brass. 300. Alright. I have a different idea too. I think what I'm going to do, so to not make this so long, 312, 330. I'm going to get my depth of cut, and then I'm going to cut the rotary phase converter off. So 330. More 343. Alright. Okay. So there, I'm drilled to depth. Turn the mill off. And turn the rotary phase converter off. Don't have to shout so loud. Alright. Now, what I could do, what would be more efficient, would be to just do like I did for drilling all three of the pilot holes, or the countersinks, just to move around and leave that number 50 drill bit in there. But since I've already got the table locked and in position, and I don't want to make this video forever, I see we're already at the 7.5 minute mark on this segment. So I'm going to do this. I'm going to take the number 50 drill bit out. I'm going to take my, let's see, I need to get a clearance drill. I hadn't planned this in advance. The clearance size, let's see, about 90 thou. So I can just do this. There we go. Use a number 43. Because that'll give me, that's just, it's 89 thou. It'll give me just a little bit the clearance that I need. Okay. So I'll just show this. All I'm going to do with this is drill through the brass. Okay, because we don't really want to be tapping the brass. And I've got a little feeler gauge here. You might be able to see there's a little bunch of dings in this thing. This is the 3,000th feeler gauge. And the reason there's dings in it is because of this. I come down, touch it, then I zero out my DRO on my drill head from my Bridgeport. And this thing never wants to zero out. You have to mash the button a million times and it'll finally zero out. Come on, thing. There we go. Alright, finally got it zeroed. Alright, so now what I can do is it tight, hopefully make sure. Yeah, alright. I'll go down, I'm going to drill down, like I said, that's 3/32 of an inch, so 93 thou, 94 thou. I'm going to go down, clear the brass. cutting fluid. Go, turn them. This is a good example of why things take so long, but it's fun, it's relaxing to me. Alright, so just touching the brass. Yep, showing. Sometimes you can kind of feel it too when you get into the substrate material, so to speak. Alright, we're good. Okay, so there we go with the clearance hole. I thought I had my precision drill chuck on here. You saw me grabbing it with both hands. Alright, so now you take the actual tap, and that thing should clear, yeah. It clears the brass. Put it in tightly. I'm going to set the beautiful thing about a Bridgeport, let me turn the phase converter off so you don't have the background noise. Beautiful thing about the Bridgeport is it has that ability to put the head in neutral, which I really like. So this is tap paste. I don't know if y'all have ever heard of it, but it's pink tapping paste. I'm not sure what's in it, but the stuff works great, and I used it extensively through my Gingrey DRO, the Gingrey Shaper project. So anyway, with the head in neutral, now the tap is locked in there, so I can spin this. I can spin the tap and I can just get it started. I'm not going to tap the entire hole, but I'm going to get it started. So get plenty of threads in there. I may tap the entire hole. But I can always come back and clean this thing up later. But the idea is, I'm sure you've seen this before from other YouTube channels, but the idea of doing this is the tap. It'd be really difficult to break a tap doing it this way, because the tap is being held by the milling machine. It's being held in the same exact geometry that the drill and the clearance drill we're in, your tapping drill and clearance drill we're in. So I really like that technique. Yes, it takes a lot longer, but I'm going to go ahead. I'm going to shut the camera off now so I don't belabor the point. But I'm going to go around. I'll proceed, do the other holes the same thing, and I'll catch you back on the next segment. Thanks. Okay, segment 2 here. I just finished, as you can see, hopefully you can see that. I've got a countersink in there in the head of the drill. It's so hard for me to see this. Yeah, you can see that. And really happy with how that came out. Let me put the camera over here. That'll show up. Oh yeah, there we go. Too bad you couldn't have been sitting there the whole time, but I just finished drilling and tapping. I clearance drilled for each hole and tapped with the 256 tap, and then after I finished that, I decided to take the little baby countersink and finish up the holes there, get the little burrs knocked off. Just did that by hand. So now I can take the thing out and put what I'll do next is finish tapping just by hand, just to clear that out with the hand tap. I think the holes are already down, but I'll put this together and just relax, and I can hold that in my hand, or I could leave it in there for that matter In fact, let's do that. Let's see. I'm really glad I got the DRO figured out. I really do like the DRO. This is an old Bridgeport that I rebuilt myself with new bearings and added, after I put all the wear parts new in there, then I added new, let me unlock it. I added the DRO, and that all was about, gosh, 10 something years ago, 15 years ago. But it's been a great hobby machine. So here we go. This is a very high quality tap, a 256 tap, and I'm going to be very gentle with it. Another thing I want to show, I've seen a lot of people break taps, and one of the easiest and most important things to do, keep it straight. You don't want any twisting motion on it. That's why I'm holding it with my left hand. And you probably can't see the tap going into the work. Let me take my left hand away. This is what I'm talking about. The tap is going in, it's almost completely in. But I keep the tap supported, and I'm just twisting with fingers, and I have the bar uniform. I'm not crossing over. I'm not putting any extra tension in there. And when I get resistance, I stop, because the tap is almost completely in, and that's plenty of threaded portion for what I need. So then I very gently, you can break a tap backing out as easily as you can break it going in. So I support it and very gently back it out, clean the end of the tap off before doing the next one. So I'll repeat the process, do those three, and I think I'll finish up tonight with another segment. I'll take this all apart and show you what it looks like inside, because I think that's pretty interesting. It's a pretty cool design. And again, everybody, for this segment, thought I'd show a little trick. I got these 256 size brass screws, and they have a hex head, and I have no idea what size. I guess I could have measured it, but that's a really tiny little head and a little tiny hex head. So here's the screws. I got them at a local hobby shop, which unfortunately has closed down. Used to be the best hobby shop in the world. They had a going out of business sale. Everything was marked. I probably paid half this for this little packet of screws. Everything was marked half off, and I stocked up on a bunch of them. Anyway, so I'm going to use these 256 screws to hold the brass plate in, the driving plate. And I don't have something handy to drive it with, so check this out. I don't know where I read this tip, but somewhere, either Model Engineer magazine, something like that. But the hex head of another screw, a socket head screw, can be used as a driving tool for a miniature hex head fastener. And of course, the vice grip adds additional utility to the device. So thought I'd show that. I'll put the last one on, and I'll do another segment where I take the whole thing apart. All right, excuse me, pardon the delay there. I had to get the right size hex head. So I'm taking the set screw out. This is the outer spindle, and I don't know if you can see in there, but it has a couple of different internal diameters machined, and it also has a little oil-light bushing, which I pressed in. I made it a press fit, just like it called for. So we'll leave that there. And here is the inner spindle, and there's a bronze washer, oil-light washer that goes in between those two. And then the smaller spindle there, it rides inside a brass or an oil-light bushing inside the spindle pulley itself. And just tonight, before I started everything, I went ahead and put that in. I put that in with a little green Loctite because it wasn't as tight a press fit as my other parts that I had made. So it's not going anywhere. I used my Binford Arbor press over there. So here's the driving plate, 3/32 inch thick brass, and as I said, it's laminated. You can't even hardly tell. If you go to my Instagram page, you'll see some action shots. I think I have action shots I made this. I bored the hole in the center, cut it out on the bandsaw rough circle, leaving plenty of margin, and then I clamped it inside this in the lathe, and I used this is an 1 3/8 piece of aluminum with a 3/8 inch bolt down the center. So I used that as my arbor to support the washer as I cleared it up. It's difficult to machine something thin. It'll wobble on you, and especially being laminated brass, I thought it'd be really good to have something sandwich it to support it. So that's what that was. So here's the driving plate. I need to clear off the back of these, kind of deburr and file or sandpaper off the super glue. It's hard to see, but I can definitely feel it. So that's that. But I'm really happy with how that came out. Here's the inner spindle. And again, this was machined out of that axle material that I got from Russ. And this goes together like this. Well, let me show you. Let me show you the whole assembly from the top. So here, hallelujah, the holes are just in exactly the right spot. I need to clear those, clean them up a little bit. Let me get a little rag. I can wipe off some of the. All right. You can see the crazy glue inside there. I'll clean that all up and deburr these holes a little bit. But just to show, this is so ingenious, and it's kind of hard to see how it fits together by looking at the picture in the book. But the upper spindle, or I keep calling it spindle, the upper shaft, it goes in, it sets in that recess there. It's slightly below the shelf that the driving plate goes into. Okay. And so that keeps it in there, and what keeps it locked down is, let me put this washer on, and it sits in here, and then once you have everything nice and snug but not too terribly tight, you can tighten that up again, and then this part fits in the pillar tool. Your drill spindle goes through the center there. The driving plate is screwed to the pulley, and it has the little tang that comes out into the drill spindle itself. I'm calling everything a spindle, I'm sorry, but you get the idea. But so the belt will go around here and drive through the driving tang. It drives the actual spindle, and the rest of this remains stationary inside the body of the pillar tool. So that's how it goes together. Like I said, a pretty ingenious little design there, and looking forward to getting this all finished. I'm making a few other parts. I'll probably do a separate video, because I can tell this one's going to be kind of long, and I'll show you some of the other parts and some more of the machining. Had some fun on the lathe in the evenings after work, making some other parts. So I'll show you that later. Thanks again, everybody. Appreciate you watching. Welcome to the new subscribers, and I hope you found this interesting. Please, like I said, give me your feedback, your notes. I'm always interested to hear what's useful or not.